Hello everybody, my name is Oleh, I'm a .NET developer, and today we are gonna to cover not so trivial topic, but the real interesting one is what's the in-memory database in EF Core and how it to use in with the example of the Blazor WebAssembly. So probably the most difficult, but the most interesting for you. So let's go. So and we have some template from scratch, and here I'm going to explain a bit about what we have as a prerequisite. So as you can see, here we have our application, which is Blazor WebAssembly, and it's hosted one. So this solution is divided into three projects. So it's the mockshop.client, which is the client part. Also, we have this mockshop.server, which stands for our server part, and we have mockshop.shared, which stands for the shared part between the client and the server. So where we can share some data models, data access objects, data transfer objects, and so on. So that's the way how we are going to use it. And while I'm being the ambassador of the most easiest configuration which is suitable for doing the task, so I'm not a fan of the overcomplication at all. So let me explain a bit about the configuration which we have here. So first of all, let's go here to the mockshop client, and here we can just omit this one. Maybe, yeah, let's also omit. So we in terms of running this whole application, so for the most brevity of the setup, we need just to run the server application, which will start also the client part, and will and the shared part will be invoked like by the way we will go. So and for this task, that's enough to have just the launch settings in the mockshop.server project. So using this, we will run the server application, and we'll run the client application by the same action. So here we have this profile, and let's look at it. So it has the name of HTTPS. We can easily rename it, but let's leave it this default way. It has a command name project. So for running this project, also we have run messages and launch browser in order to receive the detailed messages during the runtime and open the new browser tab each time we run this application. So it's for the today's workload, it's a suitable configuration, but in any case, we can just set launch browser to false when we do not want to have the new browser tab or window opened each time we build and run application. Next one is the inspect URI. So this is required to run the browser WebAssembly application this way. Also, we have the application URL. So here we have left two of them, so HTTP one and HTTPS one. Of course, we are gonna to use the second, but the first one is left just as a fallback. And here we have the environment variables section, where we are setting the ASP.NET Core environment set to development. So by this way, you can easily change this variable to the production one if you need to test some stuff with the production configuration. So that's the configuration of the client application. So currently it has just two packages installed. So the components WebAssembly and components .webassembly.devserver. So which is needed for our testing and development. And also it has private assets for all, which means that this package is installed just for the development purposes. And let's look at the program CS. And here we have quite a simple setup. So it has just the WebAssembly host builder, and it has just the initial tags, and it also has the HTTP client. Because unlike the Blazor WebAssembly application, like the Blazor server application, Blazor WebAssembly one is communicated just via HTTP client. So it's not a monolith approach like in the like you could see in the MVC or Blazor server project. So that's why this dependency is mandatory here. Also, let's look at the server. So it has currently installed Bocas package, while we have some stuff from one of the previous videos where we have generated some initial data for seeding. Also, it has components.webassembly.server, which is a package for the required package for the server part, and also it has the entity framework core currently installed, while we have the DB context here. So this one with some configuration which we have done previously. So this our testing so-called database has just 5 tables. So it has persons. Each person could have some orders, and each order has can have order details and have some products which whose are bound via many-to-many. Yeah, so there is a many-to-many relation between order and product, because one product can be in multiple orders, and the opposite way, the one order can have multiple different products. So, and configuration is done this way via on model creating method. So here, just for the simple relations, and here we have the complex one for the many-to-many relation with the intermediate table of the order product. And also we have the constructor here, because we are injecting the options during in the program CS, and we are passing them through the constructor. So that's the way. Also we have the default data with a method of the data population, which we have done in one video before. And as I have mentioned earlier, the app settings file is just one, not the app settings, but the launch settings file is just the one for the entire solution. So we do not have explicitly specified the launch settings file for the client application, while we are running starting from the server app in any case, because it's a hosted project. And here in the DAO folder of the shared project, we have some entities which are creating our database. So they all are sealed records when it's needed. The sealing and entity with ID is just the base entity, which base record for all those entities who have the ID property, and this ID property is generated on the .NET side. So it will not be an identity in this case, but in the next examples I will show how to figure out with the identity ones. Also, let's look at this one. So it has just the simplest setup, and also this one has the supported platform include browser, which means that this project is completely shared between server part and the client part, which is in browser. And let's look in the program CS on the server side. So we have here the application builder, the controller, Razor pages, yeah. Also we have the WebAssembly debugging and some basic stuff. So that's it. Also, probably for some people there is a not obvious question, but still a question about this new template of the .NET 6, which is called top level statements, where we do not have an explicit class program, method main, and so on. So how this stuff is working and what is happening exactly here, and that's why for myself I consider the JetBrains Rider a great idea, because one of its not maybe not unique, but really well done functions is the EIL viewer. So here, this one. So it's the real-time viewing of this code, which is written in C# as some low-level compiler generated code. So here we have just the IL, but obviously it's not very informative, because maybe it is informative for some kind of workloads like reverse engineering and so on, but for us as web developers it's could be not very informative. But this one has just not this one option. So there are 3 options in total here. So it's the IL, which currently we are viewing. Also we have high level C#. So let's switch to it. It's just almost the same as we have here, but without but with the naming of the compiler and with fully qualified types. So here, not just the application, but here we see that these qualifiers have become the full ones. But the most informative option is the intermediate one between the IL and high-level C# is called low-level C#. So let's switch to it. And what we have here. So the low-level C#, it means that it's not just the intermediate language which was in the first view, but it's still not the C# which is on the left side. So it's just the result of the .NET precompilation between the intermediate language and between our source code. And let's see what we have here. So here we have some usings. This is just a copyright. We have these usings, which are implicitly referenced here. So from the global usings and so on. But here we have the explicitly specified ones. Also we have the internal class program, which we are so missing in this template instead of the traditional one. And of course we have this method main. So, and as you can see, you have just the program class, you have just the method main, and you have the constructor of this class. And all this code which we have on the left side is placed just inside the main method. So it's not like the floating in somewhere or nowhere. So on the compilation stage, it's strictly placed in the main method, just it was before the .NET 6 and so on. So no reason to worry about that. And here we have all the stuff. And let's take a look at the pair of files, which are, for example, this one, to see how this stuff is working. Yeah. So here we have the entity with ID, and let's look what it has. So first of all, while it's the record here, the compiler treats it just a class with inheritance from the iQuitable. Yeah. So this way. So no record in the compilation stage. Also, we have this ID as a pair of the backend field here. So it's just the backend field, and here we have the property of the ID, which references this backend field. So what we have here on the left side is just one property. In the compilation stage, turns into the backend field and into the property with complete get and set accessors. And also we have here just the regular methods for the class, for the record, which is the class under the hood and which is obviously inherited from the object. So it has the usual toString method. Also, it has some protected methods as print members, inequality, equality, get hash code, equals, and so on. So these methods are generated anyway under the hood, and also it has the parameterless constructor, which is not necessary for doing in the code here. So because this constructor is automatically generated by the compiler. Yeah, so that was some introduction part, and let's go with our real task. So as I have mentioned before, we have the complete data model. We have the DB context here, but let's assume that we do not have any real database. And we wanted to go with this one just the most quick way as it possible. So not to create the entire database and so on, but let's assume that we have this application just for testing purposes, and we need to run it in a fast way and see whether it's working or not, and do some make some logic in the front-end part. So for this part, we do not really need the completely working database, and here the in-memory database approach comes in. So let's start with it. First of all, we need to add this package. We need to go to the NuGet here. Let's one moment. I need very interesting. Okay. Yeah, here entity framework core dot in memory. So this package, yeah, as just as it mentioned here in the description, that's the in-memory database provider, and in the brackets we see that it's usually used for testing purposes. Yeah, that's exactly what we need here. So let's add this one to the server project, and let's add our DB context this way. So we can here we can go with builder.services dot add DB context. Let's specify the type of sample context, and here we should go with options dot use in memory database, and let's provide this database with the name of the bookshop. Yeah, so that's it. That's the basic configuration of this memory database. And after that, let's try this out. But we need here to do the populate method in order to get some stuff. From this database, because for example, we can run it in this way. So let's try, but obviously currently we do not have any data in this one. So it's just has the counter and fetch data in functionality which is provided by default, but there is no error, so our DB context configuration has been succeeded. Let's populate our data with this bogus method. The limitations of the in-memory database approach include that each time we run this application, the new so-called in-memory database is recreated from scratch, and so if we have, for example, run the application one time, added, deleted, updated some data, these changes will not persist to the database. So, and this way we obviously need some data seeding. So let's go to the application dot services create. Let's try create a sync scope. dot service provider dot get service of type sample db context, and let's call populate this way. And while the populate is static void, why is static void? We can just use the more like more modern approach with the async overloads. So let's do it this way, because while still stick with the async, while we can just with sync, while we can go with the async one. So here and range async here. Now wait. It will be, oh no. Obviously there here is not the way, because we have the out modifier. Yeah. So here we will stick with the sync approach, but here it will be a sync one. And let's go to the program CS and add the await keyword. Yeah, so this way. And let's run it one more time to see whether this thing is working. Yeah, so currently no errors, and let's start with our API. So as I have mentioned before, we have obligatory to use the API approach here, so it will be the true client server, and which way we are gonna to do that. So let's go like step by step. So first of all, we need to create the API in the server project. So here in the program CS. And which way we can achieve this? Just by the minimal API approach. It is simpler than creating something like this one. So of course we can stick with the controller approach, but obviously I do not see any precautions not to go with the minimal API. So how we can do that? So it's just the application dot map. We need, for example, map get, and here we can go with the declaration of our method. So like this, and for example do some stuff. But also we need kind of maybe a service which will provide the data. And here I appreciate the repository approach. So let's create the shop repository. Currently it will be one for the server application, but probably in the while doing the next functionality we will split it to the different repositories respectful to their data. So it will be currently just the shop repository. Also we need to include private. Let's go with private read-only sample context, and let's inject this one with the constructor. So we can go with the constructor and inject it this way. So it will be the dependency injection. So we have this repository, and next we are gonna to add this service to our server side. So before this one, so and we can do it just by builder dot services dot add scoped, and let's specify of type the shop repository. here. So here will be our scoped repository. And let's create some basic method, for example, to retrieve the all users. So it will be a public list of person. So person we have here in the shared project. So these persons, it will be persons because we are following their API conventions, and let's name it this way, so persons. And it will be our context dot persons dot to list async. Yeah, list async. So this way. And also let's await it and let's do it in a synchronous way. So here we have our first API function, and let's do it in the API way. So first of all, what we need here in the minimal API is map get. So map get, and we have to specify first of all the URL, so it will be persons. Next we have the as we have the asynchronous approach, so let's stick here with the async and provide the company repository here. So it will be async this one shop repository, and what we have to do here is just to call await repository dot get persons dot persons. Yeah, so that's it, and yeah, this way. So here we have just the most simple mapping of this get method, which will get us just the list of these persons. And after that, let's go with client part. Let's do it as a new page. To the page called persons. And here we have override, and let's stick here with on parameter set async. So because this one will be called on the stage when the parameters for this page are set, and now that's the initial stage. So that will be enough. So it will be persons. Let's currently look at this example, which this is done, and yeah, so probably we could go with the initialized async, but these methods differ a bit, and that will be explained in some further podcasts. So and let's go with this approach like we have in this view, so in this page. So let's give it let's have the list of person here. So it will be persons, and here let's initialize this list with HTTP, which was the name of this client. So it's the HTTP, and one moment about the dependency injection. So let's go here to the imports, and let's see that imports, yeah. So it not here. Yeah, here we have the injection, and let's move this injection from the one page to the also we should move both these ones just to the import, in order not to do this on every page. And here let's use http.get from JSON async. Let's specify the list of person and let's provide the URL of the persons. Yeah, and also the JetBrains writer is automatically suggesting the endpoints from the server project. So that's that is a very convenient way. So we have to await this and wait. Yeah, we have missed the async keyword here. And let's give this. Let's take this page also to our navigation menu. Let's provide it a name, persons here, and let's set breakpoint to see whether it's running properly. So here we have our app initializing, and let's go here and see that our 200 persons have been successfully put it out. So yeah, this way. And also let's populate this list. So this way. And also let's go into the two approaches which could be useful for the Blazor and Web API. So the first one is the DTO, or the data transfer object, when we are going with the complete qualification, and it means that if we are passing some data via HTTP, usually we have to create the data transfer object for the data access one. So let's create a class called person DTO. DTO. One misspelling here. And let's make it not class but a record, and let's do it in more modern way. So it will have int ID, it will have string, and by the way, the DTO can handle such functionality as some string concatenation. So for example, let's say that we have the last name, first name from the data access object, but we need just the name here. So it will be the concatenation of the two strings. So let's do it this way, and age, gender, address. Okay, so it will be int age, it will be a string gender, maybe it will be, for example, char gender. Let's do it, let's alter it a bit, and it will be the string address. So we have the detail, and let's look at our IO viewer to see how the compiler treats this declaration. So very strange. Obviously, why is not? Very interesting. Probably there is a kind of case with the compiler, or not with the compiler, but with this IL view, because probably it works well with the big files, but does not read well the small ones. So let's just for testing of the scene, let's add this detail here. Let's try. Very interesting. Yeah, not. Product. Unfortunately, it doesn't generate the declaration from these records which are written in the short way. So that's very strange, but hopefully the JetBrains will fix that in the next release. So let's do this way, and here when we have the shop repository, let's have the list not the persons but the person details. And what we have to do here, so just instead of person, we have to use the projection query. So the projection query means that we are selecting from the person the new person detail, which will be a result of the properties which the person has. So it will be ID, it will be the concatenation of the p dot first name, next p last name, and also it will have the p dot gender dot, for example, it maybe first a default char, because maybe if we have the person with gender not set, but let's take into account some data, missing data, and p dot address. Probably we have forgotten the p dot age here, not. Yeah, this way. So we need to specify the arguments accordingly to the constructor. So it will be person ID, person name, age, gender, address, and after that we can go with the to list async. And let's modify our client. So and take the list of person DTO instead of person. So this way, and let's move this one to our imports. We can also do this edit third lines in order to get some alphabet order. So maybe that's the case, but unfortunately it puts the injects before the users. So not the perfect one, but let's keep it this way. And let's try this one more time. So it's initializing. And let's go here and look at our DTO. Yeah. So here we have just the DTO with all data which we have selected from our starting model. So that's it. There was not so a lot of information about the in-memory DB at all, but the key aspects of this approach here that first of all, and one more thing. Let's look whether we need all the entity framework core and the entity framework core .InMemory packages, both of them in the server application. So let's try to exclude the entity framework core and let's rebuild it. Try to rebuild. Very strange. Not strange, but that's great, because it seems that all the functionality like creating all the DB context, entity framework operations, and so on are already included in the in-memory package. So we do not need explicitly both referencing the entity framework core, the main package, and entity framework core in memory package. So we can stick just with the one here. So we have just the entity framework core in memory package here, and we do not have this package here, so let's don't include this one. So here we have just the WebAssembly and WebAssembly dev server package, and let's try it one more time just for insurance. And yeah, so everything is working fine, and in the next podcast we will proceed with the more complex queries like select queries, and also cover some key aspects of the working with data in the Blazor WebAssembly. So hopefully this video would be useful for you. If you have any comments, ideas, suggestions, and so on, please message me. I am ready for the creative discussion. Yeah,